Welcome to This Explainer. Today, we're unpacking a genuinely mind-bending hypothesis straight from our source material. We're going on a trip to the literal end of time, and just maybe, right back to the beginning. We're talking about the universe's ultimate fate, and this wildly fascinating, mathematically grounded theory of its possible rebirth. So let's just dive right into this massive question. Are we living in the universe's first life, or its billionth? To even begin to wrap our heads around whether we're on run number 1 or loop number 1 billion, we actually have to start at the end. We need to look at how the currently accepted theories of physics say our universe is going to finally close its chapter. Section 1. The cold, dark void. Right now, the general scientific consensus for the end of absolutely everything is known as the heat-death theory. And to really grasp this, we have to look at two foundational rules of physics laid out in our source. First up, energy cannot be created or destroyed. It only changes forms. So the total amount of energy in our universe is finite. It's locked in. Second, the physical space of the universe is expanding, and it's expanding infinitely. Now, put those two rules together, and you start to see the problem. Because our finite amount of energy is constantly switching forms, mass to light to heat and back, but it's simultaneously getting stretched across this ever-expanding infinite space. Well, something's got to give. Eventually, that energy spreads out so incredibly far that no forms of matter can actually interact anymore. Our source uses this brilliant analogy. It's kind of like having too little butter scraped across entirely too much toast. I mean, the butter is technically still there, but it's spread so thin you literally can't taste it. The result? A cold, dark void where absolutely nothing happens. Just forever. Which brings us to section 2, the Big Bang's expansion. Now contrast that super bleak, static ending with how everything actually kicked off, the Big Bang. It all started with a singularity. Basically, every single bit of matter, all the quarks, every atom, literally all the energy that makes up our massive universe right now was trapped in one infinitely concentrated, impossibly dense spot. And then suddenly, and without an explanation that we totally understand yet, it just started to grow. This really brilliantly illustrates the incomprehensible difference between where we started and where the scientific consensus says we're going. Look at the left. You've got the singularity, infinite concentration, everything packed into a microscopic dot. Then look at the right, the heat death, infinite expansion, everything stretched so far apart it can't even communicate. And our universe has just been expanding ever since that singularity, continuously marching toward that dark void. Moving on to section 3, the black hole survivors. But what if there's a plot twist here? Let me ask you this, and I'll give you 3 guesses. What would be the absolute final thing to be consumed by the heat death of the universe? The answer proposed by the source's hypothesis is incredibly simple, but man, it is profound. The answer is black holes. Let's do a super quick recap on what makes them so special. A black hole is a region of space-time with an unimaginably huge gravitational force. Literally nothing, not particles, not even light, can escape its pull. And because of this unyielding grip, the source theorizes that black holes are uniquely positioned to simply outlast everything else in a dying, expanding universe. Section 4. Supermassive nesting dolls. So if black holes are the last objects standing, what exactly stops a supermassive black hole from just gobbling up whatever scattered energy and matter is left in that void? Well, the logic builds step by step. Step 1. We know black holes get larger the more matter they consume. Step 2. They don't just eat stars and dust, they eat other black holes, which means they grow exponentially. And step 3, we already know supermassive black holes sit at the center of almost every galaxy, including our very own Milky Way. If we follow this thought experiment all the way to its extreme conclusion, eventually these black holes consume all the matter in their respective galaxies. Once they're the only massive objects left, these galactic center black holes become gravitationally attracted to each other across the void. They pull together and merge over and over again. Our source describes this perfectly. It's like a big Russian nesting doll. One by one, they swallow each other up until you're left with one single ultimate giant black hole that has trapped literally all the surviving matter and energy of the entire universe inside it. Section 5. The cosmic reset. Now think about exactly where this hypothetical supermerger actually leads us. Look at the comparison here. On the left, we've got the end result of our thought experiment. One ultimate supermassive black hole concentrating all the universe's energy into a single impossibly dense point. And on the right, That's the original Big Bang singularity, the point where all the universe's energy was concentrated into a single impossibly dense point. Guys, they are shockingly identically similar conditions. And this startling similarity gives some serious credence to a totally wild idea: universal recreation. If the conditions of that ultimate black hole match the conditions of the original singularity, it perfectly stands to reason that this massive concentration could actually trigger another Big Bang. It would essentially hit the reset button on the universe, scattering matter and energy outward all over again and kicking off the cosmic cycle from scratch. Section 6. The Hawking Radiation Catch. It sounds like a perfectly elegant loop, right? A universe that just breathes out and breathes back in, forever. But there is a major scientific catch to this rogue hypothesis, and it comes to us courtesy of the legendary physicist Stephen Hawking. It's a phenomenon called Hawking radiation. Turns out, black holes don't just sit there perfectly stable forever, patiently waiting to merge. They actually leak energy. They slowly, gradually decay and evaporate over incredibly vast stretches of time. So because of Hawking radiation, we aren't just looking at a simple merging process anymore. We are looking at a high-stakes cosmic race. On one side, you have the universe expanding infinitely, actively pushing these black holes further and further apart. On the other side, the black holes are slowly decaying. If the universe expands faster than the black holes can manage to attract each other, they'll simply end up too far apart. They'll be totally stranded in the void and evaporate into nothingness long before they ever get the chance to consolidate into that one single point. However, as our source points out, the possibility firmly remains. I mean, it's a race, and races can be won. If the gravitational pull of these black holes is strong enough to actually overcome the rate of universal expansion, and if they manage to keep growing and merging against the odds before they evaporate, then all that energy will be sucked into one point. The conditions will be met. The universe could indeed hit reset, exploding outward into a brand new Big Bang. Which leaves us pondering this final, honestly breathtaking thought. When you look up at the night sky, are you looking at a universe living out its one and only life, or, as this explainer suggests, are we just the latest cosmic breath in an endless, infinite chain of recreation? It's a staggering concept to wrap your mind around, and for sure, one that completely changes how we view our place in the vastness of time. Thanks for joining us for this explainer. We'll see you next time.